My name is Oz. I'm a product manager for Pivotal Greenplum, focusing on Workload Manager. Today I wanted to share why Greenplum customers use Workload Manager. I also wanted to demo some of their most common use cases. But before starting, let's talk a little bit about the setup. I've downloaded the Greenplum Sandbox VM from the Pivotal website, and you can as well. I'm running it in VMware Fusion here, and it comes with, the VM comes with a Zeppelin server installed as well. The demo is created as an interactive notebook in Zeppelin, and if you wanted to go through the demo at your own pace, I've exported this notebook for you, so you can download that at the URL shown here, and when you run your VM, you can just import it into your instance of Zeppelin, and that will allow you to just run the demo at your own pace. Okay, so without further ado, let's talk about why Greenplum DBAs use Workload Manager. There are three primary reasons. First, when in multi-user environments, DBAs need to manage policy around which user queries can consume how much of the system resources and for how long. For example, an ETL query may be allowed to run longer than most ad hoc user queries. On the other hand, queries that are run for high priority decision support may be allowed to consume more system resources than that same ETL job. WLM becomes essential when such hands-off policy management is needed. Second, as far as predictable performance, DBAs are also tasked with running their databases at optimum levels. WLM is a DBA tool for Greenplum that helps the database achieve predictable performance and throughput when concurrency increases. It allows the DBA to monitor and take action on queries using a set of rules that the DBA creates. Rules use around 100 types of data that come from the database cluster. Memory, CPU, connections, time of day, application name, username, query string, runtime are just a few of the examples. Rules then trigger actions based on complex expressions defined using these metrics, which we also call datums. The triggered actions, such as throttling or canceling a query, helps DBAs achieve predictable performance. And finally, as far as query monitoring, the query events and records are accessible via Greenplum views and can be fed into third-party monitoring tools using custom scripts. We're also planning to offer this data through our command center and also by sending SNMP traps in the future. What you see here is a very typical workflow for the DBA working with Workload Manager and Greenplum. So the first thing that needs to happen is DBA needs to create WLM rules. Then WLM starts working with those rules and records and controls queries based on these rules. And then finally the DBA monitors the offending queries. What you see here is an example of WLM, one instance of WLM events and records. You see an ident column, for example. This allows the DBA to share this specific event with his or her colleagues. All the other information you see here, such as the action that was triggered, the user's name, the name of the application that the query came from, all of these are essential for the DBA to be able to control performance and manage policy in their multi-user environments. In this demo, we are going to start by first installing WLM. Although I have installed it in my instance, if you want it to follow along, you will have to do that once you install download the sandbox. Then we are going to view the recent events from the Greenplum events view. It's going to be initially empty, and then we're going to populate it. We're going to first add a new rule to cancel long-running queries. Then we're going to use that rule and trigger it to generate an event. We will see the event that's created. Then we're going to go a step further with the rule with the rule and add to the conditional expression a specific user and a specific application name, and then we will test that rule as well. And then finally we are going to change the action that is triggered from canceling a query to terminating a session. So let's get started. To install WLM, I put down instructions here, very simple set of instructions, steps that you would have to take to get WLM up and running in your sandbox, or if you wanted to install it on a real environment, you can do so using these same exact instructions. It's very simple to do. It just takes a few minutes. But if you run into any issues, there are more detailed instructions at this link. And also feel free to send me an email. My email is listed up here, so I will be able to help you too. So first, let's take a look at the events that WLM has recorded. And it should be empty because we haven't created any rules yet. But let's just double check. I'm going to hit the play button here, and what that's going to do is the Zeppelin interactive notebook will execute the commands in the shell. It will execute them in our VM, just the same way if we gave the commands on a CLI command line interface. I ran it, and sure enough, it says no rows, so we have no events at this point. Now we're going to add our new rule. These are GP WLM commands. So first we're deleting all the rules just to make sure if there were something, and then we're going to add the rule, and then we're going to list all the rules to see that our new rule has been added. The rule here we're creating starts with a name. This is the name we gave the rule, and then it has the action. PG cancel backend is going to cancel the query that matches, and then following the when keyword we have the condition. So in our case we have if the query runtime is greater than 5 seconds set as the condition. What you see here is session ID host PID runtime, and you might be thinking it doesn't say query runtime, but in WLM speak, this translates to query runtime, and I will explain this in a little bit. And then the final clause of this rule is an including statement, followed by a number of datums that we want to see in the event that gets generated, because it will help us understand what happened a little better. So you can add a number of datums here. As I mentioned earlier, there are about 100 datums, and so you have a rich set of datums to build better context for your recorded events. So let's run this one as well. And here we go. It's our new rule is listed here. So let's take a look at scopes. As I mentioned earlier, the scope here, session ID host PID, translates to query. It's a specific query. How does that happen? Well, here we have a session ID. The session associated with that runs on multiple hosts. In this case, we have 2 hosts, and each host has 2 processes that we identify as PIDs, and any of these can be used to determine the runtime, because all these processes are getting executed. They at least start at the same time, so they are a proxy for runtime in WLM. Here is another way to visualize how this works. We have a user session. Within a user session, there's a transaction. Within that transaction, there's a query. And each query is executed on a number of hosts, because Greenplum is an MPP, massively parallel processing engine. So it distributes the load of query processing across all the hardware hosts that it has available. So here, for each host, you have a number of processes executing this query. Another way to view how queries are executed is this diagram that I have taken from the Greenplum documentation. As you see here, each box here is a process. They're running different slices, so the query execution happens in slices. These are taking different sets of plan parts and execute them in different groups of processes across the segments. Okay, so let's continue on with our demo. First, we're going to, now that we have created our rule, we need to have a user execute a query in order to see if that rule is actually working or not. So we're going to create a demo user. We're going to call this user WLM demo user, and let's play that. There we go. The user already exists, so we're good there. And we're going to have this user run a query. It's going to be a very simple query, PG sleep of 10 seconds. And our rule, let's go back to our rule to look at the runtime condition. We said if the runtime is longer than 5 seconds. So a PG sleep of 10 seconds is longer than 5 seconds. So our rule should catch this query, and our action was canceling it. So it should cancel this query. And we are running it from an app we call WLM demo app. It's actually P-SQL, but we're changing the application name just to demonstrate. But this could be any type of query management, query development application, like PG admin, for example. So let's run this. So right now the query is running. It's running. There we go. The rule caught this query and it canceled it. How do we know that this query got canceled as a DBA when we look back at what has happened in the system? This got recorded as an event in the events view, so we're going to check again. We had checked at the beginning, but now we're going to check it and we should be able to see the event that has been generated. So I'm running this, and here we go. We have our event that's been recorded here, along with all the information that we requested. The username is WLM demo user. The query was select PG sleep 10. The application WLM demo app. We have the context that includes some default information and the datums that we passed in our including clause in our rule. And our rule is listed here as well. So we have just seen how to create a rule, how to run a query and generate an event. We've seen that this whole process works. Now we're going to make our rule a little more complex. We're going to refine the condition to add, this is our original condition. We're going to now add an AND clause, and it's going to be the username. We're going to have the rule trigger only if the query is run by WLM demo user. It will not match the query is run by any other user. And we're also going to check for application name. Again, only if the application name is WLM demo app will the rule be triggered. So let's run this. So we have just modified our rule. We're going to check that the rule has been updated. Okay, the new condition is there. Then we're going to create another user that will not match the rule to see that one is matching and the other is not. Let's call this one our VIP user. Okay, the role has been created. So VIP user is going to run a query and it will not trigger the rule. So the idea here is policy management, right? There are certain users whose queries are going to be protected because they're very important. So this VIP user is running from an application called VIP app, and it's another PG sleep of 10 seconds. And the query is running right now, and it has passed, it has completed. So the rule has not been triggered for this. Now we're going to try the same exact query, but it will be run by our demo user this time. Now the query is running, and the rule caught the query and cancelled it. Let's view the recent events. Here we go, we have two records. The first record we had before, and now this second record that has caught our WLM demo user's query. So we've just seen how we can make a condition in a rule, the conditional expression, more complex, more refined to our needs. Now we're going to, we're in the last step or stage of our demo. We've enhanced the conditional expression, and now we are going to change the action. So far we have been canceling the query, with this change, we want to terminate the session that the query is running in. So this rule here, we're first deleting all the rules, then we're adding this new rule, terminate. This is the name of the rule again. This is the terminate action, and our condition has not changed. It's the same condition that we created last. And then we're going to show that this rule has been created. Let's run this. There we go. We have our rule. And then our demo user will run the query again in PG sleep of 10, and it will be the rule will be triggered. So the query is running, and there we go. The session has been terminated. We're going to take a look at the recent events. And we have 3 records this time. And let's look at the top one. There we go. This is the rule. We have the PG terminate backend action. That was the culprit for this event. So, and this is just a final cleanup step. Now that we're done, we're going to drop the demo users. So this is the end of our demo. So let's go back up to the beginning and recap. In this demo, we have seen how we've seen the events view. We have added a new rule to cancel a long-running query. Then we have refined the rule for a specific user and application name. And then finally, we've changed the action from canceling the query to terminating a session. And we've seen that that action has also been triggered, and an event was recorded as a result of that. So that concludes our demo. I hope you have found this helpful. And again, if you have any questions or comments, please feel free to contact me at this email. Thank you. Have a good day.